When it comes to motorsport, Formula One is by far the most expensive, with teams spending millions on their efforts to win. While competition is now hotting up, with others starting to take the top spots on the podium, Red Bull are still out in front with the most wins. It's clear their engineers are building cars at the cutting edge of tech. But this isn't where their design innovation stops, and their other projects might surprise you. If not, they'll certainly catch your breath. This extreme BMX bowl was built with the help of Red Bull Advanced Technologies, or RBAT, a spin-out from the racing team embarking on lots of different engineering projects.
The thing that links them all together is taking this Formula One technology and methodologies and applying it to other things. So yeah, the common theme is the Formula One tech in all of them.
These are the cars that Red Bull Racing is all about, but there are lots of bits of this tech that you can take forward into other areas.
Yeah, absolutely. So it's like you can look at this and you can see on the floor there, you can see some different types of carbon fibre, different weaves, and those materials we very much can carry forward through directly from the race car into other products. You've then got sort of more specifics, so like the actual aerodynamic shapes of like all this complexity around here. Well, it's very unlikely we'd ever take any of that and use it elsewhere. But it goes back to the tools and methodologies that we use to understand the airflow around those parts and develop those parts.
This is the BMXer Chris Kyle, but creating his unique skate park isn't without challenge. That's where RBAT came in.
They came to us to see what could we do material-wise to make it lighter, but also strong enough so that when it came down, it didn't shatter. Their initial design was steel and wood. You know, we could design it out of composites, but also you had to be able to take this apart so you can get it through the farmer's field. So there were a number of interesting structural challenges that we had to overcome. The main challenge was keeping that weight down. We had a little bit of margin with the balloon, and I think the balloon that we've ended up manufacturing was the biggest in Europe at the time.
It's perhaps not a surprise, though, that some of RBAT's projects come back to Formula One. Their most recent helping to create what could be the world's fastest drone.
The original brief was to be able to film the car and keep up with the car. And so that was what was done, and then the footage is really impressive. And so then you start thinking, well, how can that be used in the future? Where do we want to go with that? And the main thing they wanted was a weight saving. And so we looked at the drones as sort of what I call the bodywork on the outside of it, and then the sort of cruciform structure that actually holds the motor. We took those, we re-engineered them in composite materials. So I think overall we reduced the weight of the drone by about 10%. And yeah, that helped just lift that performance of the drone to that higher level so that it was able to keep up with the car. I think straight line, it's probably faster than the F1 car. I think its biggest challenge is how you stop the drone, because it hasn't got four nice sticky tyres in contact with the ground to slow it up. So it's they're pretty much having to reverse the direction of the drone and fly it backwards to actually slow the drone down. And for me, the most impressive thing there is that they're able to control the drone, flip it on its axis to slow it down, whilst still keeping the car in picture. So yeah, the pilots of the drone are incredibly impressive.
But it isn't just the super fast that they're working on.
So this is the Scarpa device that we helped Scarpa develop, and it turns your bike into an e-bike.
This little device is the creation of a startup in London.
The Scarpa unit has a motor, full gearbox, control electronics, full battery pack and battery management technology all built into one unit. So you simply click this onto your disc brake on the bicycle and away you go.
So this is where it clips on to any bike?
Absolutely. This is a bog standard normal bike, and I've replaced the rear disc brake with a Scarpa disc. Now this is the Scarpa disc brake. It looks and feels and behaves exactly like a normal disc brake. It's a little bit thicker at the back, and that's because it's hiding our full gearbox. And when you want your bike to be an e-bike, you simply open the handle, line up these metal pins with our disc, slide it onto the disc, close the handle, and just let it drop and click into place. And then we turn on the unit like so, and you have an e-bike.
And when you want it to be a normal bike, you just take it off.
Exactly.
And away you go.
Exactly.
Okay, time to give it a go. I can feel the device giving me a boost as I cycle. It's not on sale yet, but with it due to cost more than £1,000, I think I'll still be relying on my own leg power when it is. Like most inventors, Scarpa faced challenges in creating their tech. For them, it was in the gear system, and that's where they lent on the expertise of Red Bull.
If you imagine the geometry and the space around the rear disc brake of a bicycle, these are really highly conserved areas with a lot of standards describing how they sit on a bike. We had to fit a full gearbox into that space. We had that gearbox had to work in a reliable way for thousands of kilometers and be waterproof and provide low drag. So really it's fitting everything we need to do into that small space available was definitely the hardest challenge to overcome in this project.
With such a range of extreme projects, I do wonder if they ever have to say no.
I think sometimes people are shocked how much ideas are going to cost to actually bring to reality, and so that's perhaps the biggest stumbling block. The Chris Kyle stunt where he was in the bowl beneath the balloon. I mean, I remember people saying to us then, well, what did you say when people said, well, we want you to do this? We're like, well, it doesn't feel that unusual for Red Bull to come up with that kind of an idea. So no, it's never a flat no. We'll always look at it.
Meanwhile, let's go back to the real world, shall we? Electric vehicles still have many issues that need to be ironed out. The fear of range anxiety, the wait to charge them up, and limited battery resources. Sweden is embracing a different approach that hopes to tackle some of these problems. Electric roads, where vehicles can charge up on the go. Adrian Murray has paid a visit to a demonstration project in the south of the country where a new type of electric road technology is being put through its paces.
Charging up without plugging in. Could this be the future for electric vehicles? In the town of Lund in southern Sweden, I'm being taken for a spin along Evolution Road. This looks like a regular electric vehicle, but underneath there's something different. There's a pickup that means it makes contact with electrified rail and can charge up while it's on the go.
The road consists of short segments that actually switch on power under the vehicle. The power is following the vehicle, and we have more than 3 sliding contacts, so we get a steady current from the road.
The technology here isn't wireless, it's called conductive charging. Imagine a Scalextric. Electricity flows to the vehicle through a metal strip that slides along the rail. A camera follows the green LED lights to help keep it centred, while an antenna system and series of sensors ensure only specific sections have live current. And because it IDs the vehicle, the owner can be billed for their energy use.
Under here you have an antenna receiver, so the vehicle comes, send a signal. This will switch on to 650 volt when the vehicle is over it. And then when it has passed, it will immediately switch off.
Elon Road, the firm behind the tech, argued that electric roads make more sense than building a huge network of chargers.
And this is especially important when you have long-haul trucks or buses, and it's actually cheaper to build electric roads if everyone has smaller batteries. It will pay for the infrastructure.
It works for all types of four-wheeled vehicles. To test it out, a Tesla and Nissan Leaf have been modified, though there's no connection to those companies. The tech has also been applied to a local bus and even this commercial van. I think it's time I give it a go. I don't get to drive vans very often. So I'm just going to centre the van.
Yeah.
So let's see if you can get the pickup down.
Yeah.
Yeah, there we go. Oh yeah, it's following I can see the green lights,
Yes.
and it's there, isn't it?
Yeah. So now you will get the energy to drive and you will charge the battery at the same time. And when you leave the road, it will automatically go up.
Yeah.
You can continue driving for 2x the length.
But just how safe is it? having an electrical current in the middle of the road, both for drivers and the public.
We believe we have a really safe system that you cannot hack, and it will immediately shut down the road if someone tries to tamper with it.
The demo road in Lund will be here for just one more year.
This is one of the rails that's been out on Evolution Road and been tested in a real-life environment. And we take it back and we open it up to see how it has been affected by snow, water, ice, whatever.
Now, new track is being made, ready for high-speed testing in Belgium. And the startup is looking beyond cities to roads at ports and industrial sites.
If you have a broad network of charge rails or electrical road system, you don't have to carry on board all the energy you need. That means we can reduce the battery sizes. We can accelerate the electrification, but using much smaller resources than compared to it than everyone having big batteries.
It's still going to need a lot of new infrastructure to be built though, isn't it? All these rails will have to be installed.
It will require investment, but we need to do that in order to have this change. And I think going forward, it won't be either cords or electrical roads. It will actually be all of the above, because we will need so much charging infrastructure to have a 100% fully electric society.
Here in Sweden, plans are moving ahead to build the country's first permanent electrified road by 2025. So perhaps in the not too distant future, we could be powering up as we drive.
And that is it for our transportation special. Hope you've enjoyed it, and we'll see you next time.
And there's more from the Click team at